When applying equilibrium conditions to machines and frames, and remember that really the difference between the two is that the machine is one that tends to be mobile as opposed to frames being stationary. But other than that, they're typically an assemblage of pin-connected types of members, but some of which are 2-force, some of which are 3-force type members. And the key here in doing that analysis is typically to do exploded or assembly type drawings, exploded free body diagrams, and then wherever you see a pin, then you want, or attachment points, you want to replace with appropriate forces. And really the key is to identify 2-force members, such as BC is a 2-force member, pin connected on either end. It only has 2 points, so it has to have either axial or compressive forces in it, in that alone. And so then when you figure out one of these, then immediately you can then flip-flop it around where it's then attached to the other member, right? And that gives you reduces the number of unknowns tremendously, unlike here at point A where we don't know what's really going on, and so we pull that pin and separate that member out, and then we've just got 2 unknown forces that are going on there, independent, an AY and AX, as compared to our BC that's hanging out down there. Right? Look at then JK is a 2-force member again, so that one's kind of nice. There we might not know whether it's in tension or not. I'm going to assume tension and draw it that way initially. That's our JK, but now as soon as I do that, I got to make sure that wherever it was attached I put a equal opposite effect and label it again properly. Right? And that was not the only place that it was attached. It was also attached to IKE, so we'll put that again equal opposite. Space doesn't usually let you let those line all up. If you can, that's great, but they usually doesn't. But just make sure they're in the same direction. And then as we're going along here, might as well look at this 3-force member. It has 3 attachment points, IKE, and so I know that at E, well, I don't know much of anything, so we're going to put 2 there, and so an EY and EX, and then once again get those reflected over onto the other body, right? So we're doing all right. Let's not forget about point D. There's again sort of 2 forces. Didn't put any thought into what direction those might actually be working. Sometimes that's a good idea to try to figure that out. Sometimes you just don't know. But I certainly walked my way over the bucket now, and so now we got to get that they're notating H here is where the center of gravity of the bucket with its load is. But it has a pin here at G. But note that IG has only got 2 connection points. So that becomes a 2-force member that is defined in its line of action by just the line between those 2 points. Right? So that's most likely in tension because it's trying to hold the bucket up from swinging around point D. And that is member force GI. And that's what then gave us the angle over here on IKE, and why I kind of had left it hanging out there, because I anticipated that I had a 2-force member in there whose line of action was going to be given to me directly by how it was oriented in space. And from there now you have a whole bunch of little free body diagrams, some of which have 2 equations of equilibrium, some of which have 3, depending on whether they're concurrent or non-concurrent force systems, and really the 2-force members really only have 1 equation left, and really you can just kind of skip right on through those, right, in the fashion that we talked about this particular semester.